And this is it. We're going live today. This is uh, just on my banner here. Wait a second. Yeah, like this. This is QA Global Summit 2025. And please let me know if you can hear me, you can see me, you're with me, just to actually get started. Can you hear me? Yes, ready. Depends. Are you ready? Please give me plus. Yeah, all good. Hello. Give me plus in the chat if you can hear me and you are expecting to have fun all together with this brilliant uh, QA community. Yes, ladies and gentlemen, this is actually QA Global Summit 2025. Do, but what we can use AI for. So, yeah, augment, control, and evolve. And we have some nice video demonstration over there from our friends from Help Me Test. And yeah, we started uh, 31,000 members of QA community gathering. So we are sending our emails to a huge broad audience. And the idea is to gather all AI solutions in one place, explore, learn pipelines, and implement all together. And I am blessed because for like 5 years, I have great and brilliant and awesome speakers with me who supports Geekle and QA Global Summit. And if you have something to share about technology, about quality assurance, about AI, please do not hesitate. Apply to speak. And we have lots of speakers who started their speaking career with Geekle. Thank you very much, by the way, for your pluses. Let me, yeah, let me share. You can see lots of reactions here. Thank you very much for knowing me to me that you are here. Okay, going forward, we actually choose 25 solutions. In fact, we'll be discussing way more solutions than these ones, but we have 25 AI solutions for uh, automation and testing. Not just how to use ChatGPT or Gemini for test case generation or write our emails, but actually to do real stuff. And of course, agenda. Lots of happening here and lots of changes. So this is very new format we're testing this year, uh, which we call asynchronous event. Means you don't have to wait actually until we gather all like 20 speakers during 3 or 2 or 4 months as we usually do, and we shower it on you in one day. No, as soon as we found Delirian, Muhitin, and Shubham, we actually put together this blog and delivered it to you today. So it's November 26th, next one on December 3rd, and we have three awesome speakers, more and more kind of strategic methodology and approach topics, and the four more are kind of more mystery, and we're speaking with different speakers. Yes, packages. You can watch us for free online this and few sessions more. I mean, this blog and few sessions more on YouTube. And if you have one of our paid packages, you can have recordings, certificate of attendance. Of course, you have content on demand and priority access to those sessions. So, yeah, I'm blessed to actually be with you here today. And I see on the backstage my speakers. At least I see Muhitin. Brother, are you ready to say hello to the community or not? Just let me know because if you are, oh yeah, I can see you.
I am finally here. How are you?
Happy to see you,
So
brother. How are you?
happy to be here. Thank you very much. I'm good. How about you?
Yeah, I'm super excited. We have
Great.
some audience, we have some content, we have some stuff in front of us. So yeah, I'm so excited.
Perfect. So me too. Me too. It's good to be here. Thank you.
Yeah, absolutely, absolutely. All right, so I will get you back to the backstage for a while,
Sure.
and
Sure.
then you will join for a Q&A panel discussion. And now I see someone saying hello from Berlin. It means that you love BDBMZ. I don't know who you are, but you are not for the first time here because you know how it happens. People, let's share where are we all from, just to make this community interaction. I'm in Nice, France. Yeah, and I'm shooting over there, Bangkok. And give us more tips, just to let us know that we're not alone here. Hello from Kenya, and I'm gonna share these comments over here, right? And I'm so happy we have um, audience from all around the world: Chile, France, Berlin, Poland, and hi from Slovenia and Chile again. Oh, twice. That's good. Anyway, guys, we are about to start with the first presentation, um, which is let me share the yeah, which is the good, the bad, and the gauge from Lilian Yushansky, um, from JFrog. I really curious about this session, and I hope you too. Let me just check out the chat again, and the Jordan and Poland and Portugal, yeah, from all around the world. Huge community, and I'm blessed to be with you. Anyway, let's just get started and go with Lilian's presentation because this content is reason why we're here. Let's learn. Let's learn. Exciting. Let's go, guys. Yay. Cool. So I'm turning this off and let's.
Hey everyone! Today we will talk about the good, the bad, and the gauge. I'm Liran Yushinsky. Above all, I'm a husband and father, the most amazing and demanding role I have. Professionally, I lead automation at JFrog in the Aptras group. I have spent enough time in the automation world to see what makes pipeline fail and even more importantly, what makes them strong and reliable. Throughout my career, I have built automation ecosystem from scratch, everything from testing frameworks, and CI/CD pipelines to Kubernetes and cloud deployment. I'm deeply passionate about making tests stable, readable, and truly collaborative, so automation become a team asset, not just a tester tool. I'm also contribute to ISTQB's automation magazine, enjoy working with open source tools, and keep looking for creative ways to make testing more engaging. When I'm not debugging or refining pipelines, you will probably find me out at the sea. I'm certified sea kayaker, and pedaling out is how I recharge myself. Today, I will be sharing how we have been using Gage with Kotlin to simplify testing, improve collaboration, and scale automation across complex systems. Hopefully, you will leave with some practical ideas you can bring back to your own teams. So, all right, let's start with a simple question. Why would anyone want to explore another automation framework? We already had scripts, pipelines, tests, so why change? Well, I will get to that, but first, a bit about what we actually do. We're the automation team. We test a web app, APIs, and even a full Kubernetes cluster because apparently we like challenges, right? Our mission is simple. Make sure that what we release actually works every time for every user. Now, picture this, testing everything manually, every feature, every release, every tiny fix. It would take forever, right? It's repetitive, it's error prone, and let's be honest, it's not exactly the reason any of us got into tech. So, automation changed that. It lets us test faster, test smarter, and focus on work that actually moves the needle. It's all about saving time, reducing effort, and yes, getting that sweet return on investment. But of course, automation isn't all sunshine and green builds. Some tests are flaky. You rerun them and poof, they pass. And some testers are monsters. Too long, too messy, too hard to maintain. And sometimes QA, developer, and product just, don't speak the same language. Sound familiar, right? That's exactly why we went looking for a proper framework, something that gives a structure and sanity. A framework help us reuse code, centralize reports, and keep things modular so we can actually focus on testing, not fixing tests. And then there is the BDD, behavior-driven development. BDD is the glue that connect everyone, QA, devs, product. It's about writing tests in human-friendly way, so anyone can read them and understand what the system should do, not just how. So to sum it up, we automate to save time. We use a framework to stay organized, and we use BDD to turn requirements into something both humans and machines can understand. And that's where story begins. The why. Behind the framework we choose. So the good. After living through our automation pain saga, flaky tests, spaghetti maintenance, and zero collaboration, we decided we had enough. We wanted to test that feel natural to write, not like government paperwork that actually where Gage entered to the picture. Now, if you haven't heard of it, Gage is an open source tool. Is from ThoughtWorks, the same company that gave the word the one and only Jason Huggins, and of course Selenium. But unlike Selenium, Gage isn't about the clicks; it's about clarity. Gage focuses on one simple thing: making test human readable, not QA readable, not developer readable, but human readable. You don't need memorize cryptic keywords or Greek poetry. Gage just use Markdown, the same language you use for README files or documentation. And that's when we realized this could actually work. We suddenly had test specs that looked like mini product documents. Developer could read them, product manager could read them. Even one of our interns who had never seen test in their life said, "Wait, this look like notes from Jira." Exactly. That's the point. Now, people sometimes ask me, isn't Gate just Cucumber with fewer rules? And sure, on paper, they sound similar, but Gage take a much more pragmatic approach. First, markdown freedom. With Cucumber, tests started sound the same, like, I don't know, a GPS giving direction to a QA. You know, the given when then. With Gage, you just write it like a normal person. Open login page, enter conditional, verify success. No magic words, no epic declaration, just straightforward actions. Second, modular design with concept. Think of it as a reusable Lego pieces for your test. Instead of copy pasting steps across 20 files, you word them into concepts and reuse them. It's clean and very satisfying to see in action. We went from fragile test files to something that actually felt like engineering. Third is a parallel execution by default. Before Gage, running Jenkins felt like, I don't know, watching grass grow. With Gage, we could finally run tests at the same time. The day we saw the runtime drop by 17%, someone literally shouted, "We had the weekends again!" And fourth is the built-in tools that actually works. Reports, hooks, reruns, environment configs, no more hunting for random community plugins and pray. Everything just worked out of the box. And speaking of hooks, Gage gives you all the classic lifecycle hooks like before spec, after specs, etc. So instead of hiding setup logic in your test like it's a secret ingredient, you can finally keep things structured and predictable. Fifth is the automatic reruns and failure control. When a test fails, Gage can rerun it automatically. Before that, we had like the Jenkins stress ritual, a shaky finger on rebuild and silent prayer. Gage took that away. And actually, my personal favorite is the continue on failure feature hook. Sometimes you don't want the suit to stop at the first failure. You want to see the full damage report. With Gage, you just tag the step and it's keep going. It's like saying, yeah, it's broken, but let's see how bad it really is. Six is the data-driven execution. Made simple. Need to run the same scenario with 20 different inputs, for example. Plug in a CSV or JSON. Gate just do it. No loops, no code duplication, just clean specs, the scale, naturally. Seventh is the extensibility. Gage is like the teammate who says, sure, I can integrate with that. Want custom reports, new hooks, Slack integration. It's all pluggable. And the result? Readable specs is faster onboarding. New QA, devs, even PMs could jump in without any formal training. Reusable steps, minimal maintenance. Update once, use everywhere. Collaboration, it's finally real. Developer actually started contributing test packs, and they wanted to. The day I got my first PR from a backend engineer for a Gage spec, I realized we crossed a bridge. Integration with Jenkins was also a breeze, and with Slack and notification, the whole team could see result instantly. No more chasing people just to find out if a build succeeded. Slack was faster than any of us. The results were already out. And if we are talking about funny moments, we had an API test that only failed if the payload contained the word test. For a while, we called it, if I remember correct, the forbidden word bug or something like that. Even eventually, we figured out a regex validation on the server was blocking it. Gauge reruns made it easy to catch and track. So, yeah, to wrap up, Gauge help us move from a pile of fragile, noisy, over-engineering tasks to a system that's clean, readable, and collaborative. Automation stopped being a QA-only domain and become something the whole team owned. That's not just the good, that's the game changer. So we have talked about the good, the wins, the excitement, the wow moments, but let's be real. Every shining tool comes with few scratches, right? Welcome to the bad, or as I like to call it, the part where reality showed up with coffee and attitude. Let's start with the obvious one, migration pain. When we switched to Gauge, we weren't starting from a blank page. We already had a massive pile of legacy tests, J system scripts that had probably seen more operation system than I have. Migrating them was, let's say, a journey through the land of Asian code. It felt like moving houses after 10 years. You open a drawer and think, why do we even have this? Every time we cleaned up and all test, we found three more hiding behind it. Some of those scripts were so old they should have been in a museum exhibit titled Automation the early years or something like that. Then came the learning curve. Gauge itself pretty intuitive, but we paired it with Kotlin, and that's where things go interesting. Some engineers instantly fell in love with the syntax. Others look at it like it was an alien language come down from Mars. There were moments where I had explained a lambda expression and someone would just slowly close their laptop and say, I miss Java. We were basically learning two things at once, Gauge and Kotlin, which made the first few months like a boot camp. But at least the coffee was strong. Then we ran into the integration gaps. Gauge give you a ton out of the box, but not everything. For environment provisioning, costume metrics, and some dashboard magic we wanted, we had to roll up our sleeves and build our own plugins. And naturally, that meant Jenkins started protesting loudly. Speaking of Jenkins, let me tell you about our first big Gauge run. Yeah, I remember that. We were so proud. The migration was done. Everything looked green locally, of course. And we hit build. Now, with, of course, a touch of drama. And boom, every single test failed. Not because Gauge broke, not because the code was wrong, but actually because the environment hadn't been initialized properly. Slack blow up like I don't know, fireworks on a New Year event. People thought production went down. Meanwhile, I'm sitting there thinking, well, technically it's did go down in staging. That was our humbling moment. So actually, how did we climb out of the bed? First, documentation. Okay. Every time someone figure out how to do something in Gauge, they wrote it down. We created small internal cookbooks, one for specs, one for environment, one for the Kotlin tips. Soon enough, someone asked, how do I mock a pod or something like that? The answer wasn't ask Liran. It was check the cookbook. Second, pairing sessions. We started pairing QA engineers with developer. It was part support group, part coding playground. People learned faster, shared tricks, and the fear around Kotlin started to fade. It also turned into a great team building tool. Nothing bones. People like trying to debug a flaky test together at 6 p.m. And third, short step libraries. Instead of everyone reinventing login to system for the fifth time, we created a single source of truth, a central step library. Anyone could plug it in and go. That one change cut our test creation time dramatically. And slowly, the bad turns into the better. Yes, the migration took time. Yes, Jenkins made us question our life choices, but every problem we solve become part of the foundation for a stronger framework. So actually looking back, I wouldn't even call it the bad. It was just the growing pains, the messy, necessary part of evolving, and honestly, that's what made the good parts even sweeter. All right, so let's talk about Gauge. We've been using it for a while, and I will go over some real-world example to share a few lessons we learned, so you don't have to repeat our mistakes. Let's start with the basics. Gauge is all about making tests easy to read. Okay, so instead of getting lost in messy code, you write tests that actually make sense to the business. Specs. Okay, so specs, the big picture, it's your business test case. A spec can include one or more scenarios and you can tag it so you can find or run it later without losing your mind. Scenarios, think of each scenario as a single workflow inside a spec. Give it a heading, throw on some tags if you want, and run just that slice. Steps is the building blocks written in plain markdown. Step can live inside scenarios directly in specs or grouped into concepts. Each steps make maps to actually code. So when Gauge runs it, it know exactly what to do. Concept, reusable bundles of steps. Instead of copy pasting the same steps everywhere, you define them once and reuse them wherever you need. When Gauge run, it executes them and order clean and way less messy. And parameters, giving steps some extra flexibility. Step can take simple values like username or any string you want, or a whole table. Think user lists or configs, or dynamic values that show up at runtime, and even entire files. Tags. Tags is like, let's say, your little sticky notes for specs and scenarios. Just write tags and separate them with commas. Tags spec and the tags automatically flow down to all its scenario. The best part, you can tag just smoke test, for example, or just regression instead of waiting forever for the entire suite to finish. So, how did we actually run all this at scale? Behind the scenes, our Jenkins pipelines land gauge end-to-end tests that fire up hundreds, sometimes thousands of UI, API, and system tests across multiple browser, Chrome, Firefox, etc. And the feedback? It lands straight into Slack, letting the team know immediately if a build passed, failed, or got a little shaky. And for those who want more details, we have the HTML gauge reports, color coded and super readable. So actually you can see exactly what went wrong. No more staring at log that look like alien code. And here is the big picture of our CI/CD end-to-end workflow. So actually we know the code is playing nice. Okay, so if you're thinking about diving into Gauge, here are a few things we learned along the way. First is to start small. Don't try to automate your entire world on day one. Pick the tests that really save your headaches every day, the high return of investment ones. Second is to share and reuse. Build libraries of reusable steps so you are not copy pasting the same login or setup step 15 times. Less repetition, more sanity. Third is looping your developers early. Yeah, Gauge works best when the language in your specs matched to the code. If testers say restart and devs say redeploy, that's not a bug. I think it's like more than a vocabulary issue. Third is the make your reports speak. A failing test isn't enough or on its own. Add screenshots, logs, and clear notes to so anyone QA devs or product can immediately see what went wrong and where. So that's Gauge in a nutshell for us. Readable, scalable pipelines, real-time feedback, and way less headache. It's not magic, of course, but when it's set up right, it feels pretty close. And now, let's see a peek into the future. Gauge already takes care of a lot of the boring stuff, in testing, but it gets really interesting when you mix AI into the workflow. Imagine this. You write a markdown specs, and the AI instantly turns one into working steps. No boilerplate, no guesses, but steps that match your infrastructure, your API, and your style. When something breaks, AI doesn't just read the logs. It color plate patterns, understand which microservice is involved, and tells you exactly where the failure started, not just where it crashed. As the system evolved, AI learned the behavior of your test and your product. It started predicting flaky tests, warning about risky changes in upcoming PRs, and suggesting which area needs more coverage before anyone on the team even asks. And the big one actually is that AI can automatically maintain your test suite, cleaning unused steps, refactoring duplicates, updating selector when the UI changes, and keeping everything tidy without manual effort. Gauge actually already give us clarity, readability, modular steps, tags, hooks, reruns, all the fundamentals. And AI turns Gauge into something else entirely, like let's say a testing copilot that helps write, maintain, optimize, and explain quality, not just execute tests. So yeah, pretty soon the talk won't be the good, the bad, and the Gauge. It will be probably the good, the bad, and the AI that refactor the steps, stabilize the test, and open the PR before breakfast or something. Okay, so if we have a few minutes, I will show you a quick demo of Gauge in action. For this demo, I'm using Playwright with TypeScript, but actually Gauge works just as well with Selenium and plenty of other language and frameworks. And we will be testing our own product. JFrog Uptrust is an application risk governance solution that gives you end-to-end visibility, evidence-based control gates, and full context across your software development lifecycle. Let's say think of it as your app's trust control tower, monitoring every component, enforcing policies at every stage, and making sure each version hits your organization security, quality, and compliance standard before it's released. So let's start. If you can see, now you see the spec, the file of the spec, and if we will try to click on a step in a scenario, it will lead us to its scenario heading in the concept. For example, this one, okay? It leads us to here. And if we will click on the concept tabs, it will lead us, for example, to our implementation code. Let's try to check the manifest JSON, okay, where all the plugins are configured. Currently, we are using the HTML report plugin, the one that gave Gauge for us, okay? So let's try to run a scenario, or maybe, let's try to run the whole spec. So I will click Run Spec. And great, we are on. Okay, open our Uptrust web and it will go to our dashboard. It's editing and open some more pages like the activity logs. Yeah, it's quick and it's finished. Yeah, great. So actually you can see here all the flow that I ran. And here is the generated report that I can use. So let's copy that. And let's try to run it. Okay, so actually we can see here the generated report of Gauge. We can see here some info about the environment, the success rate, the total time, and of course our total specs, total scenario, what failed, what passed, what skipped. Also, if we will click on that, we will see our steps that were succeeded and also our information about each steps. Okay, nice and clean. But let's do something more interesting. Let's try to use a plugin of the HTML report that I developed with some AI. Okay, so let's try to use it in our code. For that, I will change the plugin to my custom plugin here. Okay, and let's try to run the spec. Even though I will try to run it from the CLI. So let's try. Here are flags that I'm using. I'm using a local llama, and also here is the gauge run command. Let's try it. As you can see, I ran all the specs in the spec folder. So actually it will run not just the one that succeeded before, it will run also the one that will fail, as I saw already. And it finished. Yeah, so actually, as you can see here, the first was failed and the second succeeded. Let's see the one of the report that was generated, and we will try to figure out what happened. Oh, sorry. Great. So actually, we can see the new report with more information about what happened. Okay, so we can see here the critical issues and the statute health that is fair now. Also what passed, the total scenario, what failed, the duration of the task, historical trends, for example. And actually the most interesting part is the intelligent failure analysis that show us a suggestion for the fix for this error. Okay. Of course, we can see more information about the one that failed, also the stack trace, and also our steps that were succeeded. Okay, it was nice and clean. And actually, I think that's all for me. And let's return to our presentation. So thanks a lot for listening and, of course, your time. And I hope you enjoyed and learned something useful. I had like to hear your thought, question, or anything you want to talk about from the session or something else. And of course, enjoy the rest of the conference and take in all the cool stuff. And I think I will see you around. Okay? Bye bye. See you.
And here we go. That was amazing. Let me share myself a full screen. Yeah, that was amazing, especially that UI. Yes, thank you very much, Lear. And that was great. And I hope Liran will actually join us for the Q&A session. As I see, not really much people tried Gauge in real life because that would be really interesting to hear another opinions or more experience on that. And yeah, anyway, thank you very much, Irene, for your presentation. And the next one, let me pull it up over here. So we are moving to uh, Shubham Mishra, of course, tools to test AI models. That's kind of interesting one. Yeah, just remove that because AI models, it's quite new stuff, and we already have tools for testing. Of course, you all read about that, and maybe some of you really use that, but not too much. What I mean is there is not too much experience on that, and I was lucky to find the speaker who has great and real hands-on experience with testing of with testing LLMs. And let me pull up this great speaker and great presentation uh, to the uh, to the stream right now. And kind of, yeah, let's do it.
Everyone. First of all, thank you so much for taking out time to join this session. Really appreciate that. So myself, Shubham. Today I'll be talking about something that is very close to all of us working in IT right now, the whole AI thing. Basically, the large language models, AI agents, and basically how our entire quality assurance approach is changing with this advent of AI. See, nowadays, software is not just following rules, it's an intelligent learning system, and sometimes it behaves in a way even developers didn't expect that to behave. Whatever that is, they have coded, it can behave in a certain different way. So that's a challenge that we are facing right now. And so today in like next 25 to 30 minutes, I'll walk you through what exactly are the LLMs, how these AI agents are working, why our traditional testing approach is not working anymore while testing these AI agents and LLM models, and what are the challenges we are facing on the ground level, which tools we can use, and most importantly, what is the future looks like for QA professionals like us. Okay, so let's start. That is traditional testing versus AI testing. Okay. So now the main question, why we can't just use our regular testing methods for the AI? See, in traditional applications, whether web, mobile, or backend, the behavior is fixed. and it's predictable mostly. So input is always what you give, and there is some definite output that you have to. Suppose, for example, if you want to test a login with username and password, you'll always on correct entry, you'll always get a valid output, which is that application will open. So that is very predictable. But with AI systems, it's completely different story. Some input, like same input can give you different outputs, and here's the interesting part: both outputs might be correct. Suppose you gave one prompt, and different AI agents or AI LLMs can give you different answers, but those all will be correct. For example, if you give XAI LLM to summarize some text, it will, let's say, for example, summarize differently, and the Y agent will summarize differently, but both can be correct. So now here, how do we test that? Pass or fail doesn't work anymore, right? So instead, we now evaluate the quality spectrum. So what we do here is we check whether the response is factually accurate according to the prompt that I have given, or it is the relevant questions are asked. Is it coherent and well structured or not? Is it safe or appropriate? Does it contain any biases or not? Right. So you see here, the entire approach has changed from earlier what we were checking was expected output. Now we are checking how good is the output, like how relevant is the output, how correct is the output. So for this, we will need completely new frameworks to test that, and new tools and new mindset to test that. So the traditional approach won't work here. Okay, now moving on to the next one. What are the core testing challenges that we are facing in the era of AI? The first challenge is hallucination. So this is where probably it's probably the most famous problem that LLMs are facing right now. The model will generate informations that sound like completely believable, very confident, well structured, everything, but it can be totally inaccurate. For example, I'll give you an example for this. If you ask LLM, I once asked it to give me the name of the CEOs of certain famous companies. It gave me a random name and said he is the CEO of Microsoft, but we know that I know that it was incorrect. But the LLM was sounding that it is very confident that this is the only correct answer, right? So the second is bias detection. AI models basically learn from data, and if the data itself is biased, let's say for example it has gender bias, racial bias, cultural bias, the model will learn and it can give biased answers. Okay, then the third challenge is performance variability. So even small challenges in how you ask question can give you different answers. Like for example, you tell it to explain this bug versus can you explain this bug versus what's causing this bug. So these are three different prompts, and for this LLM can give three different answers. So we need to test like hundreds of variations to ensure the consistency, right? Then the fourth challenge is ethical safety concerns. So we need to make sure that AI doesn't generate any harmful or offensive content, leak any private informations, make discriminatory decisions, violate any data privacy regulations of the country or of the organization. Okay, so moving on to the next one. What are the real world AI failures? So I've listed down 4 failures here. The first one is Microsoft chatbot. So it was launched on Twitter. It was a chatbot, and within 24 hours, it started posting very offensive, inappropriate content. Why? Because it was learning from Twitter itself, where users can post anything, and some users deliberately tried to corrupt it, and there was no adversarial testing done, no red teaming were done. Big lessons for everyone, right? Microsoft had to call it back. Okay, second one is Amazon's hiring algorithm, wherein I mentioned earlier that AI is trained on like a large amount of data. So in this case, it was trained on Amazon's 10 years of hiring data, but since the most applicants were historically male, so it got biased towards hiring the male candidates and picking up the male candidates instead of females. So that's where this problem occurred. Then the third one is Tesla autopilot incident, wherein autopilot really works well in normal condition, but in certain edge cases where this problem happened, where it was identified that some unusual lighting or some missing road markings or some unidentified objects can cause the car to crash, because it was not trained over that data. Then the fourth one is AI misdiagnosis in healthcare. So there have been many cases wherein AI diagnostic systems have given completely wrong diagnosis, and because they were trained on very limited and diverse, not diverse data sets, so they can give like inaccurate diagnosis for the patients. Okay, because see, in the healthcare, like patients come across from different geographies and the diseases or the diagnosis can be different, but the AI that was trained was on a specific data set, so it couldn't judge the patient's disease correctly. Okay, next let's move on to the next one, which is essential AI testing tools. All right, now the good news, there's tools available to test and tackle these challenges as well. So I've listed out some tools here. So first one is Guesscard. So basically this is an open source platform which is great for flexibility. It's good for automated vulnerability detection, bias analysis, etc. And if you want to check whether your model has some hidden biases, you can go ahead with this tool. Then the second one is deep evals. So this deep evals have become quite popular recently. It provides very useful matrices to test output. So like it gives the relevancy score for the outputs given by the LLMs. Then there is some toxicity detection also. Then it tests for the factual accuracy also for the answers given by the LLM, which is very useful when you need quantitative measurement of the quality, basically. Then the next one is PromptFu. This is specifically for those working in the prompt engineering domain. So it lets you test multiple prompts variation across different models. You can compare these prompts and optimize your LLM to give the best result for every prompt. Then the next one is Langsmith. So this comes from LangChain team. It's more of a debugging and for tracing purposes where your AI behaves unexpectedly. So basically Langsmith helps you to trace through entire execution flow wherein it sees what went wrong through the entire execution flow, and it helps developers to debug and correct those faults. Then comes TrueLens. So it basically provides you deep observability into your AI system. It doesn't just tell you what the output was, but it tells you why that output was coming from your AI system. What influenced this decision, like which part of your inputs were most important for the output that LLM gave. Very useful for understanding the model's behavior, actually. Then Azure AI Studio. So it's enterprise grade software used by the larger organization. So this basically provide enterprise grade testing with built-in safety evaluations and compliance testing for the models. So yeah, you don't need to learn all these tools, but yeah, just start with some and get to know about these while in your journey, and because these are becoming standard right now. Okay, moving on to the next one. Okay, testing methodologies for LLMs. How do we actually test LLMs? What's the methodology basically we are using? So there are three major focus areas here. So first one is prompt engineering validation, then the response accuracy assessment, and third is the safety protocols. So basically for prompt engineering validation, you'll be needing to test same functionality with different ways of asking questions, because in real world users don't follow a script, right? They even ask different questions. They have different ways to ask a same question. So you test with direct prompts, conversational prompts, ambiguous prompts, even prompts with spelling mistakes, grammar mistakes, and the model should handle these variations reasonably well. So the second one is response accuracy assessment. This is the core of LLM testing. For the response, you need to evaluate multiple things, whether it is factually correct, no hallucinations should be there, is it relevant, coherent, it should be safe, no bias is there, etc. The third one is safety protocols. This is where we internally try to break the system. We do red teaming exercises, trying to make models say inappropriate thing, jailbreaking attempts, trying to bypass safety and all. So yeah, these are the three things. And now moving on to the next AI agents testing strategies. So now testing AI agents is even more complex than testing the LLMs because they involve different LLMs coordinations. Because they don't just generate tests, they basically perform some task. They take actions, they integrate with external systems, they make decisions and have real consequences. So we need to do test four major aspects. So first one is behavioral testing, integration testing, multi-agent testing, and the fourth one is performance testing. Coming to behavioral testing, so it says, does this agent actually complete the task it was assigned for? Can it handle errors properly? If an API fails, what's the fallback mechanism it has to follow? Does it inform the users appropriately about any failures? Does it handle some edge cases or not? So these all comes in behavioral testing. Then coming to integration testing, agents use various tools like they call some APIs, they will query some databases, like they will access some external systems. So we need to check the agent's integration with all these different systems which for which it is meant to be, and based on that we'll perform the entire integration testing for the entire workflow that agent will go through. Okay. And the next one is multi-agent testing. So this is where it gets really complex. When multiple agents are communicating, collaborating, unexpected behaviors can emerge here. So what if two agents give contradicting information, and if they get in an endless loop, how are they going to get out of it? What if agent A's output format does not matches B's input format? So these all things are tested in multi-agent testing. Then next is performance testing. So basically we do load, stress, latency measurement, scalability, because see, these agents can run 24/7 in production environments. So we need to do performance testing to check how reliable they are. Okay. Coming on to the next slide, we have future of AI testing. So I've divided it into three phases. First is self-healing tests. So imagine if you are an automation testing expert, you test some scripts, and what if it automatically starts fixing themselves? So that can happen with AI, right? So if the test fails, AI can analyze why it failed, understand the test scripts, reruns it, and if there is some fixes needed, it can do it on its own. No human intervention is needed. This is already starting to happen, and we have a lot of tools for this. So the second one is predictive QA. So machine learning models can predict which modules are likely to have bugs, right? Even before deployments, based on some code changes, some historical defect patterns, complexity matrices, etc. So that before deploying to production, we can judge what is wrong with the system, and we can fix that rather than breaking production. Now the third is autonomous testing agents. Fully autonomous systems that design test cases, execute and analyze the results, report bugs, even like it can update your test scripts as well. So we are moving towards these things. Okay, so these are some facts that I have listed down here. You can go through this. And now let's move on to the next slide. Let me show you a demo how we can automate LLMs. We can do evaluation of an LLM using DPVals, one of the tools that I've discussed earlier, and the LLM would be Claude. So what you are about to see is a practical solution, how like we approach a problem, and how do we systematically measure whether our AI outputs are actually good or not. Okay, so in this I'll just walk you through a small implementation wherein we use Claude not just to generate the responses but also to evaluate them. Like I'll be using Claude for both generation and evaluation purposes. So yeah, so the first thing is a quick background that I want to give you, that DPVals is basically an open source Python framework that is specifically designed for testing LLM application. It basically provides some built-in matrices like answer relevancy, some drift calculation, etc., which we can apply on the LLMs to basically test them. So the key here is basically LLM as a judge approach. So basically DPVals uses another language model or an LLM to evaluate a different LLM. So while this might seem circular at first, but research shows that Advanced models like Claude and Claude are basically objective at assessing quality whenever when we give clear evaluations. So here in our demo, I'll be using Claude for both for testing and evaluation purposes. Okay, so let me show you what are the three components that I'm going to use in this. So the first one would be a Claude wrapper that I'll be using. In this, so DPVals has a standardized way to communicate with different LLM providers, whether that's OpenAI or Anthropic or any other. So in this, like I've used Claude, so I'll be creating a Claude wrapper code that is written here, if you guys can see. Yeah, so here I've used Claude 3 Haiku model. So because it's very fast and cost effective in running the test cases. And then the second thing comes is the test case. So so this is how a test case looks like. And each test case has an input, output, and an optional retrieval context, which is crucial for any RAG systems. So where you need to verify whether your model is using the right source for the information or not. Then the third thing is to run the evaluation. So here, this is the code to run the evaluation. So herein we configure the matrix. So in this demo, what I have done is I have used answer relevancy matrix, and for this, the threshold that I'm keeping is 0.7. So that means like 70% and above is a passing rate. Below anything is a fail response for that LLM that we are testing. So once we run the code, I'll show you how the response looks like. So you can see the console has printed these things. The answer relevancy score is 10, threshold 0.7. Then you can see there is a reason as well. So basically, this what does this mean is like your LLM has passed the test for the answer relevancy, and there is a reason section as well. Like if you can see that it is showing the score is 10 because the output has directly and accurately addressed the questions. So this is a parameter wherein the DPVals will let you know like why your answer was correct. So this is all for the demo. Thank you. Right. So what is the implementation roadmap looks like? So I've listed down three aspects or 3 points for this roadmap. The first one is foundation and integration. So basically start by assessing your current capabilities, what infrastructure does you already have, what is missing, and then select some right tools. So basically do not try to adopt everything at once. Pick 2 or 3 tools that fits in your immediate needs, and then try to integrate those with CI/CD pipelines and try to play around with that. Then the second is optimization and expansion. Once the foundation is in place, refine your testing strategies based on whether what you're learning, expand some test coverages, add more scenarios, more edge cases to test the LLMs. Then you can create different monitors, dashboard that can predict incorrect LLM behaviors. All these are done in this phase. Then the third phase is continuous evolution. This is not so basically this is not a one-time project, right? It is an ongoing journey as AI will be evolving. So keep adopting to some new emerging technologies, new tools that are coming in. Try to implement that in your project or in with your product. So yeah, so that is all. I think thank you so much for this session, and thank you for patiently listening to me. And if you guys have any questions, we can move ahead with those. Thank you.
Yes, thank you very much. Thank you very much, Shubham. Ladies and gentlemen, well explained session. Don't you think so? Uh, I learned a lot actually from this session, and I'm a co-founder of Zero Docs. Yeah, I started up at Geekle AI Labs, and we use Longsmith, and I guess we will use some of those techniques very shortly because we have sometimes some issues with the LM responses. Anyway, thank you very much to our speaker, and I saw someone say, "Hey, if this talk was written with AI, I mean, guys, are you serious? I mean, try to generate this talk without all that experience the brother has. And if you can, maybe it's possible, but I'm not sure. Anyway, thank you very much, and we're moving to the last session of this chapter, and let me pull it up. Let me pull it up from our website. Yes, you can see that. And yeah, the last one is AI powered test automation. Ask UI Deep Dive by Mohitin Stambologlu. So yeah, let's do it. How do I? Yes, this one, and I'm adding this to stage, and I will try maximize it this time. Okay.
Hi everyone, I am Muhittin İstanbulluoğlu. I'm a senior test automation engineer and working in Test Solutions GmbH in Germany. So I'm dealing with test automation for a long time, and I would say I'm working on the AI-powered test automation for the last 1.5 years. And since January this year, I would say for the last 11 months, I'm specifically working on the SQI test automation. So today, I will discuss about my experiences with AI-powered test automation, specifically SQI. So here is my agenda for today. I will discuss a little about the challenges of the traditional test automation, modern test automation tools, and then I will switch to the AI-powered test automation as a concept. So how it works, so what we mean exactly with the AI-powered test automation, and then I will jump into SQI and I will discuss what is under the hood, so how it works, how the processes are achieved. Then I will discuss about the SQI unique capabilities, and then I will show you some execution videos or demos. I will make some demos as well, and then we will discuss about the pros and the cons. So we will look at two sides of the coin. So at the end, as of today, so when we say the test automation, we mostly land on the DOM, on the HTML code, and we locate the element using XPath or CSS or how you work on it with your ID or name or class or whatever. But that's good. So it works. It's fast. So it's all good. But when there's a new release or something changes on the source code or something changes on the UI, then you start some issues. So you have some breaks with the locators. So you have some flaky results. So then every release or every changes will become a kind of a nightmare for you, right? So that is actually, I mean, something you have observed many times, probably in your career. If the application under test has different platforms, like for example, it's running on the web version or the desktop version, mobile version or whatever, so you mostly create different frameworks for each and every platform, and then you maintain and you construct all these versions from different platforms. So that's also for me a challenge. And regarding the desktop app test automation, so that's also I mean, doable, but it's not achievable with the existing tools in the market like Selenium, WebDriver IO, or Playwright. So you need to use some special tools, some special skill set. You need to do some workaround. So that is also, to me, like I can say, in a challenge category. Another challenge for me is the contribution of the existing QA members into the automation business. So it is regarded as the test automation is for test automation engineers. So we cannot get much contribution from the manual testers, for example. So, but by using the AI-powered test automation, so we can involve into their efforts as well into the automation business. Let me put together the AI-powered test automation concept, so how it can mitigate the challenges that I have discussed in the previous slide. So there's no locators with the AI-powered test automation. That means you're not landing on the DOM or HTML code. So once you see whatever the application that you will be testing on your screen, that's enough. So the screenshot will be taken, will be sent to the server side, it will be processed, annotated, and then the action will be on top of that one. So that's actually the basic concept with the AI-powered test automation. It is not getting the support from the AI, but it is exactly using the AI itself as the automation. So that's two different things. With the AI agents, actually I should use agents only. It's not AI agents. So when I say agent, it's clear, but to make it easily understandable, so I prefer to use AI agents. So the vision agent, for example, for SQI example, the vision agent will take the screenshot of your tool or application that you will be testing, and it will be processed on the LLM sites. So the OCR text will be detected, everything will be detected, and then some will be some action. So that will require some mental process. So it's not just you just move on your step and then everything will be clear. No, that loop will be circling around. So once your objective is achieved, so that is something I find actually really cool and kind of mitigating the challenges that we have experienced before. That means with these two, you can test automate anything visible on your screen. Doesn't matter whether that's a desktop application or it's a web or mobile, or doesn't matter. One single platform will be ready and will be available for every platforms. You don't need the locators, you don't need anything, so it will be just executable for you. And by the way, you don't have to throw away your existing framework. If you are, for example, currently using Playwright, Cypress, Selenium with Cucumber, BTD, PyTest, or Behave framework, doesn't matter. So you can integrate, for example, with the AI powered test automation tool. For my case, it's the SQI, and you can use in one single platform, one single tool, and you can test everything as long as you can see it on your screen. And in this one, you don't need very deep technical coding skills. So you don't, for example, using the NLP, natural language prompt, just like you are chatting with ChatGPT, for example, or Perplexity. So you will be typing what is the context, what is the objective that you want to achieve, what are your, for example, tasks or execution steps. So you can be general about it, you can be very specific. So if you are general, you leave some space for the agent to make some mental process. But if you can be very strict, you can narrow it down what you want to do exactly, and then it will be executing exactly what your objective is. So that is basically the basic concept of the AI powered test automation. Let's pop the hood together and see how SKI works. So that blue framework at the top is your local machine. So you will make small installations on your local machine, and then you will have two important elements in your local machine. So which is one of them being the SQI UI controller. That's like your hands and arms and legs. So doing the actions on your local machine and interacting with the application. And then the SQI control client. So that's like your brain. So it's kind of a middleman between your local machine, your local computer, and the server side. So here is how it works. So you're testing an application, you pop it up on your monitor, on your screen, and the screenshot will be taken by the controller client, and it will be sent back to the server side. On this server side, every text, every icon, every picture, every logo, your radio buttons, and everything detected will be evaluated and will be annotated, and everything will be put together and sent back to your local machine, to the controller client. And in the controller client, those annotated screenshots, so with every single element is detected, visible element, and looking at your code, what are your instructions or your NLP, what you want to achieve, then the controller client will start executing your commands on top of those elements and will start executing through the UI controller, and UI controller will be doing the action. So then this process will keep going until the end of your script or your instructions. So then your automation process will be happening in this way. So with the annotated image or screenshot, that's actually how AI sees the world. So everything on your screen is detected and annotated, and then now you can interact and you can do some actions on top of those annotated screen. As I mentioned before, the AI-powered test automation tools, for my case, that's being the SQI. So it's not working in an isolated environment. So you can integrate with your existing framework like Playwright, Cypress, Selenium, or any testing tools like the Cucumber BDD, Behave, or PyTest, or PyTest BDD. It doesn't matter. So you can integrate any reporting tools, for example. You can integrate on one single platform and one single framework. You can use all your you can test automate all your platforms and everything as long as they are visible on your screen. Doesn't matter. So you don't need to worry about the UI changes, flakiness, or some other stuff. So as long as they are visible on your screen, that means you can automate it. So before I jump into my implementation architecture, let me discuss about the SQI version. So SQI as of today offers two versions. So one of them being the TypeScript as the primary programming language, and the Node.js, and the on this one, Jest framework will do the orchestration on the background. On the second version, you will be using Python as the programming language, and the PyTest will be doing the orchestration on the behind. So those are the two versions, and the Python is the fully supported version as of today, and the TypeScript version is currently doable, so you can still work on it, but in the future it's not decided yet, but sometime it will be deprecated. So I have constructed and started with TypeScript and the Node.js version first, and I think I implemented like 6 months with that version, and then I switched to the Python version, and I've tried Cucumber BDD with TypeScript Node.js, and I switched to Behave, PyTest BTD, and PyTest with the Python version. So on the web interactions, so I'm currently using Playwright. So I have integrated Playwright successfully into my SQI framework. So then I can seamlessly switch between web to desktop, desktop to web, or mobile, doesn't matter. So on one single framework orchestrated by SQI, I can still switch to, on the first line, I can start with the Playwright, for example. On the second line, I can switch to SQI, do some action here, and then I can switch back to Playwright. So all are possible. Regarding the reporting, so as of today, I'm using Allure HTML reports for the client side, so that they have the nice and the fancy pie charts and everything. And for me, I use the simple HTML reporting, which kind of a screenshot for each and every step. And that's helping me a lot with the debugging, and I understand what's going on. So that's basically for me, or for the developer, or for the automation engineer, and the Allure HTML reports for the client. And if you have some other reporting tools, or you can customize any of them in the market, they are all welcome and you can integrate. And the good thing with the Allure HTML report right now is that I got the full video recording of the test execution, so the client can see in the report what has been achieved in this test scenario or test case. So the next one would be it's a very actually beneficial for end-to-end testing. Like I mentioned, you can test various platforms on one single test framework. So you can switch to anything you want, and you can start from mobile and end up with desktop, or with the web version, doesn't matter. You can achieve everything, every platform, every operating system, as long as you can see it on your screen. So the AI agents are working on the traditional element location. So with the OCR recognition, they are basically locating your text elements visible, visible on your screen. So they are detected by the OCR recognition, and there are some other tools used for the image recognition, like the vision agent, for example. And you can use the natural language prompt. You can just describe what you want to achieve, your goal, your execution steps, and the SQI ask, act, or get commands will be executing all these instructions on your behalf. So here are some additional codes on the AI-powered automation, specifically SQI. So I have already discussed about vision agents and the LLM models. So the agentic approach. So agentic is coming from the term agents. So that's the AI agent basically. So it's kind of using a perceive, reasoning, and the act loop. So once you want to, for example, using the NLP, you can describe some set of actions or some objectives here with the context, with the objectives, and with the tests and everything. And then it will obtain the data from your screenshot, will work on that one, will do the action, and then will kind of mental process or thinking process will happen whether the objective is reached or not. So if not, then it will keep doing, it will correct if there has been a mistake in the previous step. So that's actually a cool feature. So it's not like hard coding your automation steps, but you can kind of do through the agent with the agentic approach, a kind of a mental process here until you reach your objective in terms of test automation. So another cool feature I like is the AI elements. So let's assume that in the annotated screenshots, the element that you want to interact with is not very clear, very small, or it's kind of a merged text or whatever. So what you can do is you can make it more visible and more interactable by taking a screenshot with the combination of a logo with text or a picture or whatever. So you can make it easily detectable through the AI so that it can interact with it easily. So you can train your OCR, which is another cool feature. I like it. So let's assume that you have a text, two different texts, but it's been merged, or vice versa, exactly the opposite. So you want to have two split texts, but it's been merged. So you want to split up or you want to merge. So it's up to you. What you can do is you can train your OCR on your workspace for the SQI. So you can take the screenshot, what you want to train on your OCR, and then you can correct it. You can type the correct version and save it. And then from that point on, your OCR will be doing the same kind of behavior for that type of issues that you are facing. So which is also, I like it. With the another web based application or tool that you can use in terms of test automation is the Caesar. I'm going to discuss a little more on that one. It's exactly working on your web browser. So when you land on the SQI homepage, you will see the Caesar button and you can easily try it by yourself. So you need to make a small installation settings on your local, and then you keep using on your browser. You don't have to code. You don't need a framework. You don't need an IDE. So you will just type your text or your instructions in a natural language prompt style, and then the AI agent will be doing the job for you. So these are actually the additional tools that I would like to discuss. Let's see right now SQR, how it works in action. So this is actually a kind of a execution. Don't focus on the right side, please. So you have seen this on many times, I believe. But on the left side, you will see that the code is written in plain English. And on the bottom, on the left side, on the black side, the execution is being reported back to me by the AI so that I know what's going on. It's kind of talking to me on the execution. So that is pretty much the execution. Let's switch to the Caesar, which I have promised before. So again, if you land on the SQI homepage on the web browser, you will see that you will try Caesar button here. Once you click it, and then you will see what happens. So again, I will just right now share with you the execution of the Caesar on the browser. Again, I'm clicking the try Caesar. I have previously done the installation on my local, so that's why. And I select the web, Android, or computer agent, which is for the desktop. and then I type my instruction here, what I would like to achieve. In my case, in my scenario, I will land on the booking.com, and I'm gonna book a flight from 9th to 12th December round trip. So the language will be English, the currency will be euros. I'm gonna close the pop-ups, or I'm gonna decline the cookies and everything. So with like 5 lines of instructions, so I'm achieving all these purposes. I don't need a IDE like PyCharm or Eclipse or VS Code or whatever. I don't need to construct a framework. And by doing this, you can also integrate the efforts of the manual testers into the automation business. There is no coding here. You just type your scenario, you just type your test cases, you just write some instructions in the NLP form, and that's it. And it does the work for you. For example, here, if you notice that, so the leaving from is Frankfurt, but the going to is actually Berlin airport. So the deal is fine, but the travel dates are fine, and it will probably change. But so when there is something wrong, it revisits the previous step and talking to you on the right side. Did you notice that what has been done and what has been not? So you are also able to see the execution. I mean, it's not happening in a blind area. You see exactly what's happening, and the execution of the automation will happen all once together, and you can follow what are the actions as of now. So that is basically a cool feature. I like it. So with SQI, you can write your code or script or how you name it in 3 different ways. So you can use the traditional automation with the coding, interacting directly with the element, using these like some actions like click, type, locate, wait, or whatever. So that's the first option. And the second option is directly using the agents. So using the SQI agent.act, agent.get, or ask commands. So here, you don't need to locate the elements. You just type in what you want to achieve, your task, your rules, your context, for example, your objective, what you want to achieve. If you want to leave some space for the agent to make some mental process on behalf of you, that's the second option. And the third option is you can combine the traditional way of coding plus using the agents. So that's why we call it agentic. In this hybrid version, which I use a lot, the hybrid version, so I can combine the traditional way of coding plus the AI commands or agent commands like act command or get command or s command. So in one line, you can go with traditional, or the second line, so you can get the power of agents into your test automation. And then you get at the end, for all 3 options, you achieve your goal. All are doable, just given as options for you. So let's look at the 2 sides of the coin. Is everything perfect with the AI powered test automation? So I have already discussed the pros, good things, the listed green color here. I'm gonna more discuss or more focus on the cons, on the negative sides, which I observed. Again, this is from my point of perspective. So these are my personal observations. So with AI-powered test automation, as I described how the process works, so the screenshot sent to the server, being evaluated, annotated, sent back to the client, and then the controller will execute the action, and then this step will looping around. That's why it requires some performance overhead. So when you compare with your existing automation tools, you can find SQL a little slower because of that processes on the server side. So there might be some delays due to the server process times or latencies. OCR, for example, the text detection, sometimes some can bring some flakiness. The text, for example, in this run, everything works perfect, and the second run, the same text could be detected differently. But thanks to the SQI that we had the AI element description or the OCR training feature, we can work around. We can solve the issues to mitigate the issues. But again, these are the things that you can observe and that you can face during your execution. So debugging, why sometimes become opaque, so not clear. So you maybe, it requires some initial learning curve to understand the logic with the working with the agents. So there are some dependencies like your internet speed, for example, your processor power, your screen size, your resolution. So because the image is taken as a screenshot and sent back and processed and annotated and sent back to your local. So that type of process requires some dependencies like I mentioned, internet speed, processor power, and so on. So once you have the power on these elements, probably you will have faster execution times and the better resolutions and better executions of the automation. And of course, unlike the free automation tools in the market right now, so the test automation, test AI powered test automation tools, for example, SQI. So they are coming with a price ticket, so they are not for free. But for the companies, they have good options which you can one-to-one work on it, and probably you can get a company license, and then your team, everybody in your QA team can work using the test automation. So I think that will conclude my presentation for now, and I will be more than happy to answer your questions in the Q&A session if there are any. Thank you very much and appreciate for your patience.
Yes, that was great. Actually, I love this session. Very practical one, and I see Muhitin and Shubham on my backstage. Guys, I'm inviting you to turn your cameras on because we're moving to the panel Q&A session. All right, fellas who are listening to us, please give us some emotions, some thoughts. Let us know you are here, and yeah, do not hesitate to ask questions in chat or in a forum or wherever you are feel comfortable with. And I have my speakers on the stage. Hello, Mahitin. Hello, Shubham. How are you guys? Again.
Hello, Ed.
Hello, Ed. Thank you. We are good.
Thank you. I'm good.
Thank you very much for really great sessions, very practical ones. Both AI actually heavy, but quite clear as for me. I'm not the automation test engineer, but quite clear for me. And what was really interesting for me that both Liran and Yumuhitin, you are not actually associated with the technology you are presenting about. So you are users, as Liran said to me, and Yumuhitin mentioned to me in my in our conversation previously. You're just users who who invited or decided to present, and that's cool. It's cool. All right, so yeah, unfortunately Liran in some flights, and of course the plane late, and probably he can't make it in time, but we hope he will. Anyway, we got some questions and lots of stuff to discuss. And first, I would probably pass to the mic to you, Mohitian. Probably you have some, I don't know, first opening words, maybe questions to Shubham about his talk about the LLM testing or whatever it is, and we'll go from there.
So thank you very much, Ed. Like we discussed before, so my objective with my presentation was I was not promoting any of the tool or any tool in the market, but to share my experiences as a test automation engineer dealing with the AI-powered automation test automation tools for the last one year. That was actually my point. So I try to look from the both sides of the coin, not only the good things, but also the things which I'm not very happy with it. So I'm not gonna say the bad or negative sides, but I would say could, I mean, the room for improvements, let's say. So put it that way. So that's actually my objective, and like I said in my presentation, I will be more than happy to get questions if there are any from our from anybody joining our session today.
Right. Thank you very much. I have at least six, and I'm copying them. This one for Shubham, sorry, and no, I'm copying them into the program, and we'll discuss them later. All right,
Sure.
Shubham, any thoughts to start?
Yeah, just thank you, first of all, for inviting me for this talk. So yeah, I was just excited to share my views on AI testing, the new things that are happening right now in testing world. So yeah, that's it. I think I'm ready for the questions.
Yeah, I love questions, and why don't we just jump straight there? And first goes right to you, Shubham. How to maybe you can read it for us and answer if you can.
Yeah, sure. So, how to document a bug or failure if the output is not strictly wrong, right or wrong, but simply not useful or low quality for a given prompt? Yeah, sure. So, the tool that I discussed, DP so there are some matrices and some scores that the user gives, the tester gives, to check whether the output, basically in AI, it's not just right or wrong. There is no black or white. It's something gray areas are also there. So to test that, we generally give out the scores to the output that are there, and based on that, we decide whether the answer that the LLM has generated is correct or not. So it's basically, we see how relevant the answer is, how correct it is, how contextually correct it is, and is there any biases in the answer or not. So yeah, that's it.
Okay. Thank you very much. Thank you for answer. And next question goes to you, Muhitin. And here we go. Could you please read it for us?
Yeah, how does the tool handle temporary success messages like a saved pop-up that disappears in 1 or 2 seconds? Since the tool takes a screenshot, sends it to the server, and processes it. That's a very good question, actually. For my case or for my application under test, I didn't face that 1 second or 2 seconds of pop-ups, but it can easily handle the pop-ups. You are right, but if you are sure about that there will be a pop-up and it's going to be a short period, what you can do is, like if you remember in my presentation, I said you have three types of coding. So one is the traditional way. So you have a specific command that you can make a screenshot. So then you can take a screenshot after you click something just before you got the pop-up, and then the screenshot will be taken, and then you can work on that one. So that is doable. But that's a very good question. You are right. So I mean, you can also set the screenshot period or the agent to look at your monitor period. So if you just lower the time, and it will be visiting frequently. But there are two options, like I said. So either you can just play with the revisit time or the screenshot time, or you can use manual screenshot command.
All right, cool. Shubham, we're next.
I think he's frozen, or?
Something wrong. Can you guys hear me and Muhitin? Please let us know. Yes. All right, let's go to, I hope Shubham will come back soon, and we move to another question.
So you mentioned screenshots are sent to a server for processing. If I'm testing an app with real customer data or sensitive, personally identifiable information on the screen, is there a way? Yes. So you can use the on-premise solution. You can go with the AI servers, plus there's a hybrid version. But here, do not think that when I said the information or data not being taken into the server, so it's just the process. So the AI is taking your screenshot, making. I mean, it's not storing anywhere. So, but this is the reality. This is what is happening right now. But if there are some strict rules in forms of the data security or something, you can go with the on-premise version, and then we will be. I mean, I will be more than happy to support you in this journey. So if you like to go with an AI-powered test automation for your company or for your project.
Thank you for answering, Muhitin. And here is Shubham, and he is back again, and right in time to your question, brother. Let's do that.
Okay. So, what are the most unobvious practical prompt techniques as a manual tester can use try to make a model produce harmful or biased? I mean, why would you? But to test that, yeah, like we can like give different types of prompts. Like I cannot tell you what exactly the techniques are there to be prompt, because that will come under prompt engineering. But yeah, as a tester, what you can do is you can frame a question in different ways, like with different you can say biases or ideologies. You can put in that question, like to make the LLM produce a certain answer. So you can do that. But yeah, there are other ways for which the prompt engineering would be the best thing to like study. Not
All right. Thank you very much. And we have one question on YouTube. It goes to you, Muhitin. Yes, I think a question more on to Muhitin. Have you used AI to analyze screenshots in test? Miro can generate diverse AI content on the canvas, and we need to validate correct rendering. I feel like,
Oh,
guys, Miro is here.
yeah. If I am not mistaken with the question, so uh, I didn't specifically try with Miro or something, but I can basically say that I have implemented two different AI-based test automation tools, and for both, you are able to take the screenshot as long as you can see on your screen, it is doable and it's workable. So you can get the content, but I didn't specifically work with the Canva or Miro in my projects. But like I said, I believe so. I'm just guessing right now. So you should be able to do this. Yes.
Probably the question is about, sorry?
Yeah. Go ahead, Ed.
Yeah. Probably question, maybe the question is about the size of the screen, because canvas is kind of, I don't know,
Yeah.
has no limits, and how it behaves this way. But probably it kind of, I don't know, can resize it or something like that. I don't know.
Yeah. Yeah, I mean, in your automation, you can select the or you can set the your resolution, your screen size. So you can. I mean, if that helps, I'm not technically very professional with the tools that you are speaking about. So maybe there are some specific tips and tricks on that one. I might be missing, but I give you the general concept and idea, and then I think you can just walk through there. So you can set the screen size, so you can just make it narrow or big. So if it is smaller screen with the resolution, then you can work faster because there is less elements to work on. With a bigger screen, with a more resolution, so you have a lot on your screen, so that everything will be evaluated. So if that is that was the question, yes, you can scale it, you can manage it. But if there are some technical details, requirements, I'm sorry, I'm not that professional enough to answer that question.
Yeah. Thank you, and Anton, if you have any details on this question, feel free to follow on, and we will try to give more perspective or whatever you would mention. And we're moving on to the next question to Shubham. Let's go.
Yeah. So after identifying a questionable response, what is the fastest, most practical way for a manual tester to tag that specific output so that engineering team can use it? Okay. Okay. So first of all, collect all the response, like the answers that or the artifacts that are being generated by your tool, or even if you are doing manual testing, you can test the llms, and like based on certain set of questions that you have prepared, and based on that, the quickest way is to like tag the exact prompt and response pair, and provide it to the developers, and check it with different already existing AI tools out there, like say for example ChatGPT or Claude, to test how the answer that your LLM has given is comparable to the already existing standards. And then you can create a bug out of that, like keeping your question answer pair and what is generated from some standards or some benchmarks that you guys are following, or and then you can reply back to developer to with that, so that there can be more refinement based on that exact prompt or context.
Thank you very much for your answer. And going back to Muhitin, could you please read that one?
Sure. If I have a page with two cancel buttons, one for a model, one for the page, and I tell the AI to click cancel, how does it decide which one to pick? I mean, does it guess or does it fail and ask? So if you are not providing more details on what you want to achieve, you have like two options. So it's going to pass or fail. But here you can be more strict on what you want. For example, you can say that click the cancel button at the right bottom side of the page or on the pop-up screen or whatever, so you name it. Okay, if you provide more details, or another way is that this is the way with going with the agent, so describe them with an act command, for example. Or you can go with a traditional way. You just locate the click button which you really want to click if there are more than three. For my test, for example, scenario, I was working on a table, and each row there, I mean, I would say there were identical buttons, so which I want to click and kind of expand. But because they are all identical, so I had to go with some workaround here. So what I did was I created a function, special function, and it was taking me clicking the and element. So whichever element, for example, I would like to go with, foundable on the screen. So I was passing that, for example, the third element on the screen. Then you can go with something like this. So if I know the order, I know the AI will start working from left top to just analyze. So if mine is, for example, the second one, I can specifically say with the kind of an index. So I can say the second element, or I can go with the location, top, middle, left, right, or whatever, or I can locate it. So there are many ways, actually, not one or two. I mean, if I think maybe one more minute, probably I can come up with two more options.
Cool. I like it. And Shubham, how do we practically implement cost control mechanism in the automation framework to prevent tests from excessive burning of tokens? I guess you are muted. You need to unmute, brother.
Okay, I'm really sorry for that. So yeah, the tools that I showed in the presentation are mostly open source tools, except for some that are enterprise grade. So one of the tools that I showed demo, DPVals, so it captures your exact sorry it is a open source tool, so we can implement that using like our existing if suppose for example we have an automation team that is proficient in some Python language, so we can leverage their uh, capabilities, and over the top of that we can use this tool, which is a Python library plus so with some AI knowledge we can implement this with really low cost, and we can use some LLM models which can be for this for the testing purposes. What happens is generally the companies or the organizations have their own LLMs on which we are testing. It's not like that we are testing on some um, enterprise or some existing LLMs, which like for example Claude or Chat GPT or DeepSeek, etc. Because so in the test environment, if we are testing our own LLM, we can what we can do is we can first check for what prompts they are giving us a short answers, and which can save the tokens, so that those answers we can first check on the existing on the LLM that is existing, or which can act as a judge to see like whether we are getting a short answer, a token saving answer or not. And then based on that we can design our test cases, so that once the test cases run we can minimize the tokens that are being wasted on judging your LLM from a standard LLM that acts as a judge.
Cool. Could you please share the name or even the link to this tool in private chat here, and I could actually share with the community in the comments, because it sounds
Sure.
really
Sure,
nice. Thank you very
I'll do
much.
that.
We're moving on, and Muhitin, to you. Since this relies entirely on visual recognition, how does it work in a standard CI/CD pipelines like Jenkins or GitHub Actions that run headless Linux containers? Do I need a virtual display? Maybe, probably.
That's a very good question. So you can also integrate AI-powered test automation tools, for example, for my case, SQI, and you can execute your tests in the CI/CD pipeline. So if you are going with web browser, so the headless modes are also possible with that one. But for the Linux containers, if there is a headless way, so you are able to go with the CI/CD integration, and you can execute your tests in the CI/CD pipeline. For example, I know there is an integration with GitLab, Jenkins, and some other CI/CD tools as well.
Yeah, cool. Thank you very much. And going further, Shubham, how to ensure the stability of external APIs and data sources they integrate with, so that agent failures aren't falsely reported due to temporary integration issues.
Okay, so to minimize this, what we can do is we can take some pretty standard external APIs as a judge to evaluate our LLM on which we are testing, so that as they are already tested and they're out there in the market, so we can take them as a judge, and based on their output we can judge the output of our LLM. And yeah, so that's it, I guess.
Thank you. And the next one: how do you guarantee that the exact same prompt will result in exact same action? Oh my God, when I read
Oh,
about guarantee,
you,
guarantee
you,
that
unfortunately, you cannot guarantee that. So, I mean, there are some engines and mechanisms are running behind. Not you don't have to wait, by the way, wait for 100 times. So in the maybe the last 10, you can have some flaky results. So that's possible. That's why we have the AI elements so that you can define your own element as a locator, take it as a locator, so to make it more precise, so you don't get some flaky results. Or there might be some OCR detection, or your OCR engine could be failing, so merging two texts together on the next run. So these are the normal nature of automation, so that's happening. So no one can guarantee that you're going to get the same results in the 100 execution, unfortunately. That's the AI technology as of today. We
this,
can't do
this,
anything.
this is a completely new era of software where you cannot actually guarantee it will work as it's supposed to be working.
Well,
Anyway,
yeah,
yeah.
if you don't mind that, I was in the German testing night in Berlin last week. I did the same presentation in there, and me personally, I believe that I said the same thing. I will share the same idea. Me personally believe that. So if you say, for example, the crawl, walk, run phases, with the AI in test automation, I think we are still in the crawl phase. So it's not even walking. It didn't even stand up. So I believe by the time things will get fast and fast, and we will be doing the same job probably way different way, because right now I see in the market many tools are ready there, but no one cooked them yet. So
Well,
that's my
yes,
point.
that's why guys like Shubham, they actually do their job. They are trying to evaluate the LLM responses and maximize the most proper outcome as possible. Am I right, Shubham?
Right, exactly.
Yeah, yeah, yeah. And I have question from the audience, few actually. And first was, I am concerned with the pricing for AskUI. Why would a company go for it? And another or the same one, this the same user asks, how would you convince the company to invest in adopting AskUI or similar tool? I guess that's a lot of pain in this question. How would you guys approach that?
I mean, me personally, I'm not from the marketing team, so I'm a technical guy. To be honest, I don't care with that type of stuff. So I will be honest with you. So it's not my business. So I never question that one. But there is a good reasoning in this question. So I believe in the market, as I know, SQI was in the at the top list for the last month or something. I see in the LinkedIn that their CEO has shared recently. I see that companies are paying their license just because they get some benefit out of it. Otherwise, nobody would just pay your license price for nothing. So, but think about that. You are doing a critical business and you are investing a lot for the testing or automation. but this is a legacy desktop. You cannot do your job with Playwright or with other tools. So you need to do something different which can handle your desktop, your legacy desktop application. So in that case, the AI helps a lot. The tools like SQI, for example, help you a lot so that you can automate it. But very good question. Very good question.
That's a great question. Thank you very much, Rock. And probably what I would add on top of that is guys will definitely need to invest in something for sure, and in something AI. So we're just sharing great proven technologies or tools or whatever. And I know the CEO of AskUI for years now. They support Geekle for years, and I know they are serious and for a long here. So I'm not related to AskUI also and to any other testing tool. But anyway, it's nice to mention that. And two last questions. First goes to you, Shubham. What are your suggestions on how to maintain and update the library of acceptable golden answers in our automation suite, especially when the underlying LLM is frequently outdated with a new, sorry, with you
Yeah.
something.
Okay, so this depends on what kind of a LLM your company or your organization is making, whether that is a RAG system or some kind of a chatbot which answers to a specific type of a questions. So the golden answers can be framed like those. Suppose if that is a chatbot or chatbot for some food delivery company, so the questions that it would answer would be something related to some restaurants or some food choices or some places where you can find this food or that food. So the answers can be framed like that, and depending upon that we can update the golden test suite according to the context or the feature that the LLM that we are developing is providing to the end users.
Cool. Thank you very much. And the last one in this chapter, if AskUI updates the backend AI model or the OCR engine, is there a risk? Cool question, actually, that my existing passing tests will suddenly break because the new model interprets the screen differently. So we're getting dependent on that.
True. I'm not experienced, or to be honest, on the backend side of the SQI. I'm not from SQI, by the way. I'm just a test automation engineer implementing SQI in my project. But as I know, so they are using different OCR engine and for different AI models for Android, for example, mobile and the iPhone mobile or some other tablet versions, or depends on what you are using or which version of SQI you are using, like the TypeScript or the Python version. So different OCR engines could be running on behind. Whereas, so if your existing tests are passing, so I mean, are we talking about a kind of a traditional automation suite? So normally they will not change by the SQI codings or the functions. They will still be existing there. In my current project, for example, in the same test scenario, I'm switching from Playwright to SQI. On the next line, I'm switching to Playwright again. So that's doable, possible. So you don't even have to use two different frameworks. In one single framework, you can use different tools with the orchestration of the SQI. That is actually, that would be my answer, to be honest. So normally, like I said, I'm not the SQI guy from the technical knowledge from the backend, but from my understanding as a user, your existing scenarios or scripts will stay the same, so nothing will change. Whereas the technical details, I think, should be asked to SQI guys or not.
Yeah, it's a question more to ask UI guys, or sort of guarantee questions. There's no guarantee, guys. It's super new technology, and it's always trade-off. Those risks on the one side and benefits on another, and the you are the only person who decides whether it's worth it or not. It's always like that. So probably we're not there, even with this extensive LLM testing, like we heard today. We're not there yet, or at least we don't know how to do that. Okay, thank you very much to the audience. Thank you very much to my great speakers for this top level content we heard today, and for your time, energy, your smiles, and for being and supporting this community. So the chapter 1 for QA Global Summit 2025 Autumn Edition is over. And yeah, see you in 2 weeks. We'll have 3 more great topics. Let me share the screen from the website again. Thank you very much. I don't want to chat. And yes, the age of verification from Perlagushi, great actually framework how to verify AI tools for your work. And high fiber count from Amir Shani. Lots of great experience on teamwork and communication improvements from Meta, and Nachum Dimer, context-based text automation reporting and analysis. Also, I expect really great and deep session we can learn from. Again, thank you very much. And to those who still don't have tickets, to have all these recordings, certificates, access to all these upcoming chapters and sessions, I have a small hint for you. Wait for Black Friday. Thank you very much for your time, and see you in 2 weeks. Thank you, gentlemen. Thank you, Shubham. Thank you, Mohitin.
Thanks for the invitation.
Thank you
very much. All right.
Bye-bye.
Bye-bye. That is all.